Welcome to the MSQL Tips webcast. Surprise! Welcome to your first cloud bill, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MSQL Tips and today's webcast host. Joining me today is Joey D'Antoni. Joey's a senior architect and SQL Server MVP with over a decade of experience working for both Fortune 50 and smaller firms. Also joining us is Dave Bermingham from SIOS, who's a cloud and data center management MVP. And today they will cover what you need to know about the cost of moving to the cloud. Before we get started, if you have questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you're not already a member of the MSQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Joey, and he can get started.
Thanks, Greg. One of the reasons why I was really interested in this topic is one of the ways I knew cloud adoption was getting bigger and bigger was I had more and more customers start complaining to me about how much their cloud services were costing them. And that was my first major indication that, you know, people were really into this Azure and AWS thing, is that people were using it enough that they were complaining about cost. And I've been working with Azure and AWS, frankly, pretty much since the beginning. So I've gotten to kind of see the services evolve over time. And I put this together just to kind of quantify what the types of charges you're going to see are, where your opportunities for saving money are going to be, and then remembering everything that's included in your cloud bill, so you can kind of justify that value to your upper management if you have to. I always say the biggest difference between cloud computing and traditional on-premises computing in terms of cost is that we get a single bill for all of that positive and negative. What that means is your management knows exactly what IT cost. This is good and it's bad, because IT can be kind of expensive, but it can also allow you to demonstrate real value to your company in that you're saying that you've saved, you know, certain X amount of dollars off the top of the cloud bill. So we'll go through all that today, and we'll have a couple of polls, and you'll learn about some of the SIOS technology that you can take advantage of in the cloud. I'm Joey D'Antoni. Like Greg mentioned, I've been doing this for 20 years. I'm MVP. The pertinent things here are you can find me at Twitter at jdanton. If you have any questions after the webinar that I didn't get to address, feel free to hit me up there. Also, I blog at joeydantoni.com with no apostrophe. So you can find my blog there where I'll talk about a lot of these topics. So let's have a quick poll just to see where you are in your journey towards the cloud. And Greg, if you could fire this off.
All right, so everybody, just take a few seconds to answer this question, and then we will share the results. I get a good amount of people, so I want to give this another 10 seconds, and I will stop this and share the results. All right, let's see what we have here. So we have 50% said currently exploring, 33% have dev tests in the cloud, 8% use the cloud for DR, 8% said majority of workloads are in the cloud, and 0% are saying no way to the cloud.
Very interesting results. And our next poll, which is going to be immediately after, oh, sorry, wrong way. What is your biggest cloud fear? And I'll be curious to the response for this, because I've seen this change over time.
And just give us 5 more seconds. We got a good amount of people who've already voted on this one. All right, I'll close that down, share those results. So we have 37% said cost utilization, 33% said security, 13% reliability, 13% said management, and 4% said availability.
So I find that really interesting. I'd say probably as recently as 2 years ago, you would have seen those numbers extremely lopsided on the side of security, which is a testament to, I think, more people using the cloud and having some better understanding that Amazon and Microsoft and frankly Google are all very secure platforms, and you can make them as secure or frankly as insecure as you'd like. But in general, the security is just as good as in your own data center. The security part of that is basically a non-issue. It comes down to a configuration issue. So we see more people asking about cost management or cost benefit and management. The other thing that's kind of interesting was the previous poll. We have a lot of people using cloud for dev tests. So I'm going to talk about that, and that's one of the places where you can save a lot of money. And so when you get your first cloud bill, this has happened with almost every customer where I've done any sort of a cloud migration, is the first bit is it can be really expensive. And I tie this back to in on-prem and colo models. A lot of times you don't know how much everything costs. Everything here has a published price, and it adds up. You pay per disk, you pay per VM. And for some services like network bandwidth, you get all these incremental charges that you may not have been expecting. Even with certain types of storage, there are charges for how much I/O you do. The other problem that happens in a lot of organizations is a number of people have access to the portal, and they add different services, and people don't know what's what. In the worst case that I've seen happen is that the cloud admins decided the bill was too high, and they just kind of randomly went through and started deleting stuff. That's not a good thing either. So we're going to talk all about this in this talk. And then finally, what are all these data charges? So we'll talk about networking and how your network design is really, really important in the cloud, because this is almost a universal tenant. I'll have a few universal tenants that I'll mention today. Almost every cloud provider, and I count cloud providers when I'm talking about cloud as Azure, AWS, and Google Cloud. Everybody else is pretty far behind those three, but all three of those vendors, all of your data into their cloud is free, so you don't have to pay any bandwidth charges on any of that data. You do, however, have to pay for downstream data. So for example, if you had a user who had data in Azure, maybe a terabyte database, and they were pulling all of that data, or a significant portion of that data down into Excel on-prem every day, that could be quite expensive. So that's one of the caveats you want to avoid. So, but we'll walk through each of these and talk about different options for reducing your overall cost. So our agenda. Overall cost, how to lower. So we're going to talk about some strategies around sizing VMs, turning things off and on. That's believe it or not, a very common principle that a lot of organizations don't take advantage of, and it's some flexibility that's built directly into just about every cloud platform. You need to understand what costs money and what is free, just like I talked about that data example. One of the other things that's free in the cloud is load balancing. So load balancing within a single region in Azure is free. If you wanted to have a load balancer on-prem, you'd have to call F5 or Cisco and pay a lot of money for that. So that's another kind of neat thing. And it's important when you're doing presentations to management or things like that, that you present the bundled value that comes into the cloud, and not to sound too much like a finance talk or a used car salesman, either way, but there's a lot of bundled value into the cloud, and we'll talk about some of that as we go through specifics. We'll also talk about cloud design principles, and I'm going to mention one thing probably a bunch of times throughout this talk, and if there's one takeaway from this, I'd like you to have this. It's nearly always cheaper to build a bunch of small things than it is to build one really large thing in the cloud. Unfortunately, that doesn't always work for our database servers, because we can't easily scale out our workloads without a lot of work. We'll discuss some approaches to that. But you design applications for cloud world differently than you might for on-prem, because you can't kind of infinitely scale up. There are very large boxes. I know the largest box in Azure currently is, I think, 128 cores and 4 terabytes of RAM. However, those boxes are very expensive. I think that box is like $19,000 a month in terms of compute cost. So you want to think about how you design carefully, and we'll talk about some of those options. And then finally, we want to make sure we can identify the resources we've created, and we'll talk about the methodology for doing that. There's a kind of notion that's, I think, kind of comes from Google and some of the things they've done in site reliability and built into Kubernetes, but it's applied across cloud platforms. So your first bill. This has happened to a few of my customers. I try to prepare them now that I've been through this process a few times. The most common things that happen are too many people get access to the portal at first, and they just start to spin up the resources they needed. We saw this. So back when I was an enterprise architect at Comcast, we built our own private cloud, and it didn't actually have a monetary cost to it. Obviously it did, but we didn't have chargeback. So it was very difficult for us to show applications how much cost they had. We built that tooling into the cloud. However, the teams chose not to believe that their applications cost that much more. In a cloud computing world where Microsoft or Amazon send you a bill, it really costs that much. You have to pay that bill every month, or they turn your stuff off. It's a little bit different than an internal world, and it's important to understand that differentiation and be prepared for that, and take advantage of some of the pricing resources that are out there to have a better idea of what it's going to cost as soon as you get involved. So let's take a quick poll here of what tool you're using for workload utilization management, because it's going to lead into our next couple of topics.
All right, give us like another 10 seconds here, and then I will share the results. All right, let me close this down and share. All right, so we have 80% said none, 14% said other, 4% said cloud health, 2% said
so
clouding.
None.
So none is 80%, and cloudability is 0%. So 80% for none.
Yeah. So that's really an interesting scenario. So as you do your migration, I like to think of cloud migration projects as not too dissimilar rather, than from when we went to virtualization. So when we virtualized our physical servers, in the late 2000s, 2000 aughts, and into the early teens, we took a lot of different approaches to virtualizing things. I remember a lot of VM admins wanting to push down the size of our servers, and you may have that same pressure when you move into the cloud. So there's no real magic here in terms of RAM and CPU. If you need a half a terabyte of RAM, you need half a terabyte of RAM. It's not a huge cost savings, and you can't really shift that. So the traits of really large, really expensive cloud bills. The first one is a lot of very large VMs running 24/7. So I'll say this. This is another tenet of mine as to how I talk about cloud computing. If all of your workloads are very monolithic and very large and run all the time, the cloud might not be a good fit for you. It's just the scenario that large resources are expensive, and reserving those resources costs a lot of money. And that's something to be considerate about. Even in our private cloud, creating very large VMs was problematic, just because you're tying up a lot of resources, and frankly, you're when you have those large resources, you're screwing up Microsoft's capacity planning. Secondly is incorrect application of software licenses. So something to consider here, particularly when we talk about SQL Server and to an extent Oracle, is the fact that you can either rent or bring your own license. So especially, and this is a little bit specific to Azure, in the Azure portal, when you see the image you're choosing, if you're choosing a SQL Server image that does not have BYOL in front of it as a prefix, you're renting your SQL Server license from Microsoft. That can be a good deal, but it can also add a lot of cost to your licensing. And Microsoft will let you bring your license. So it's important to note that you can do that. And if you have a license on-prem, it's perfectly valid in Azure. The other scenario is non-production machines that are in use all the time. So a number of you had talked about your development environments being part of your cloud infrastructure. And the important thing there is that if that development environment is not used 24/7, don't necessarily use it 24/7. We'll talk about ways you can do this in terms of automation, but you should have those machines running when the developers need them, and if they don't need them, they don't need them. Also, you could think about resizing them during off periods. Another one is misunderstanding of service structure. I ran into a customer last week where someone had deployed Cosmos DB, which is one of Microsoft's databases as a service, which has a relatively high cost of entry, but scales pretty well. So like it's expensive to start with, but if you have a lot of data, it can be really good. Well, the problem was they didn't have a lot of data. They had 12 meg, and it was some developer wanted to learn Cosmos DB, which was why they were using it. And they were spending, it wasn't a huge amount of money. It was about $400 a month, but as a total percentage of their cloud bill, it was a specific, it was a very high percentage. So that was quite challenging. And then finally is bringing back a lot of data to on-premises. As I mentioned earlier, there are one or two scenarios where it's possible to not have to pay for downstream data. They usually involve a very expensive direct connection to your cloud provider, whether you're using ExpressRoute or Amazon Direct Connect. But if you have users that are returning data back to on-prem all the time, that's when you may consider having something like a data warehouse back on-prem, so you're only returning that data once a day, rather than by active user queries. So right sizing is also very important. Just like we talked about with virtualization, you don't want to oversize because you're going to have increased spend, whereas with virtualization, you're going to not have the density you'd like to have. Undersizing will result in unhappy users, so you can't just like say, oh, this server had all this capacity in the cloud and on-prem. In the cloud, we're going to cut that capacity in half. So understanding things like the performance of your storage is also very important. One of the kind of interesting things I've run into is that you really can't build database servers on non-SSD storage in the cloud because there's no fast spinning disk like you have on-prem. It's either you have SSD or you have really slow storage. In fact, like the only thing I really use Azure standard storage for is demos of how SQL Server works with slow storage. And collecting that data upfront is key. One of the really nice things about the cloud is both in all three vendors collect a lot of metadata about your servers. So it's very easy to see a performance baseline of what a server looks like once it's in the cloud. But frequently it's very hard to collect that data from on-prem if you don't have a tool in place, or you're trying to collect, perfmon data across 100 servers and do analysis of what sizes your VMs should be. So you really want to think about that and take advantage where possible of things like application scaling and auto scaling. That doesn't really work for our database servers because it's not like we can just auto scale a database server because the database engine has to restart. But it can be helpful for your app tiers and other things like that. So strategies for migration. I said this earlier and I want you to remember it again. Always remember many small things are cheaper than a few very big things. This doesn't really help with database servers. However, if you're building a database a new application in terms of your database structure, you may want to design for scale out, or as we call it in database world, sharding, where you kind of effectively partition your data across multiple databases. That's one design pattern that I see used frequently. Another is to design your apps to take advantage of caching to reduce your database workload. This is something that can reduce a great deal of work on the server. So if you're not familiar with Redis caching, Redis is an in-memory key value store that you make application calls to, and then in turn, if the data is not there, Redis will make a call back to your database. However, what this can do is reduce the needed size of your database cache and overall database server. I've seen scenarios where it reduced database workload by 60 to 70%. And getting that caching server tends to be a lot cheaper than building a very large database server or a very large database if you're using platform as a service. You can also use features like automation to shut down your resources that are not in use 24/7. So those development VMs, Azure has a feature called auto shutdown. By default, it defaults to 7 p.m. UDT, which is 2 o'clock Eastern typically. And ask me how I know, because I've done demos where it's like, oh, the server's down, and I thought I'd set it to 7. So just be aware of that. But that's one way to do this. So one of the kind of interesting things about that is you may choose to set up auto startup too. That's not an option. You have to kind of configure that yourself. But frequently in the customers I've been working with lately, we just configure auto shutdown, and then we give the developers or DBAs permission to turn on the servers as they need them. Another thing to do is think about your backup strategy. This is kind of an interesting scenario, and it's going to be a little bit uncomfortable for those of you who are long-term DBAs. Don't worry, I'm not telling you to do anything crazy, but you still need to back up your data. But you want to think about how you're doing it. And first of all, the first point of that is that you don't necessarily need to back up everything. You need to back up your databases, and for example, in Azure, you can back up that data to blob storage. But there's no reason to back up your database server after you've done that database backup, because it's way faster for you to deploy a new server than it would be to restore your old one and then restore the database backups, paying for all that extra data to be backed up. Another example of this is app servers. Remember, all of your infrastructure is now code, whether that's PowerShell or command line scripts like Amazon or Azure. So you can quickly rebuild your infrastructure if you have problems. So you should be able to deploy everything in a nearly automated fashion. That's my take. So back up your databases and really think carefully before you back anything else up. Really, the only thing I reserve for backups like that are complex application servers that can't be installed automatically. Other than that, it should be in a script, and you should be able to just regenerate the application server at that point. The final thing is understand your cloud vendor's costing model for each service. And this gets complicated, and you almost need a PhD in cloud to do this, because I teach Azure all the time. It's almost my full-time job, not quite, it's probably half of my job. And it's hard for me to stay on top of all the new services that get added each and every month. The problem is, aside from VMs, which have a fairly constant pricing model and are really straightforward, each of the services can be priced slightly differently. I mentioned Cosmos DB earlier. If you tried to figure out the Cosmos DB pricing model, I think you'll like qualify for a PhD in economics. It's quite complex. There's bursting charges, and there's all sorts of various configurations you can do. That's probably the most complex end of the spectrum. SQL DB, on the other hand, is way less complex. So if we're talking about Azure SQL, which performance level you choose, and there's an additional charge for storage, but it's pretty much a straight line bill. If you're using VMs, like I mentioned, the VM cost is straightforward, but your networking and your storage costs are going to be added onto that. Azure and Amazon both have some great pricing models. And one of the kind of interesting things is there are different costs between regions. So I'm going to swing over here, and I'm going to go to the site called azureprice.net. And this simply does VM, so it doesn't do any platform as a service offerings. But up here, we put in a region which is West US, and then we can see the best region for cost for a given VM size. So let me scroll down to some of our more database-centric VMs. So I'll shift memory. So you can see, for example, the GS5, which is a somewhat common database VM where it has 32 cores and 448 gig of RAM. Compared to West US, the cost is 19.1% lower per hour in UK South. And likewise, we see this E64 v3 is 10% cheaper in US East than US West. Obviously, you can't always change regions because sometimes you have user latency issues to think about. But if you do have a service that can go cross-region, using a service like Azure Price is something you may want to look at. Other strategies, so prepay, this is a pretty huge thing as well. And let me just show you the Azure pricing calculator to show you what that looks like. This is frequently one of my favorite sites. And I know I'm making this a little bit Azure centric, but just about everything I'm talking about applies to AWS as well. So I'm gonna go to West US 2 because I'm looking at a very specific large VM here. That I'm not seeing, but okay, we'll just go with the G5, or actually, excuse me, the E64. And so just to show you the difference between SQL Server and SQL Server licensing and OS only licensing, here I can see what my pricing is. And I don't think that's pricing that accurately. That's kind of weird. Let's close that and try this again. Virtual machines, view. Anyway, we can see we have savings here if we choose, and I'm not sure what's going on with the calculator and why it's failing like this, but we can save up to 43% if we reserve it for 3 years, and we can save up to 29% if we pay for it for 1 year. That's really substantial pricing savings. That's something to be aware of. The kind of interesting thing, and I'm going to talk accounting here for a second, one of the things your finance people like is the fact that the cloud moves what is traditionally a lot of capital expense or long-term investment into operational expense. So instead of buying your servers and depreciating them over time, you're actually you're paying them month by month, more like an electrical bill. So there are some different tax handlings around those sorts of things. However, if your finance people want to keep capital expense, which some organizations do, it just depends, this is definitely where you pay up front and use those cost savings. Evaluate your regions where possible. Some regions can be much cheaper than others, like we saw in that other demo. Remember what's included too. So you're not having to run networking. All your networking within your data center in the cloud is built in. You have things like load balancing that are additionally built into that. One of the other things that's really cool is your storage bill is your storage bill. So your RAID configuration is built in to your model. So you don't have to pay, when you buy 1 terabyte of storage, you're getting 1 terabyte of storage, but it's actually 3 terabytes because both Microsoft and Amazon use a similar model where they have 3 copies of your data. And finally, of course, this is kind of obvious, but power and cooling are also included in this model. And that's something not a lot of people quantify. I know that was something when I was at Comcast and we tried to build that into our costing model. We struggled just to get that data. and figure out how much our data centers cost and to operate. But that's something a lot of organizations are kind of challenged with. So some basic tenants that you should always be aware of. You're always going to pay for compute. So if your compute's running, you're paying for it. There are options where you can pause things. For example, Azure SQL Data Warehouse lets you pause. There's some other service I ran into this week that lets you pause. And if you stop your VMs, you're no longer paying for them, of course. But if you're running, you're paying for that. Your storage is probably going to be cheaper than on-prem. I just mentioned the low cost of RAID, or the built-in cost of RAID in cloud storage. In my experience, buying a lot of on-prem enterprise storage, your storage in the cloud is going to be cheaper, and you also have really cheap long-term storage options. So if you happen to work in one of those industries where you have to keep copies of backups for 10 or 20 years because of poor decisions some executives made 20 years ago, you can do that, and the cost is pennies a gig. So storage is almost always going to be cheaper. Compute's probably always going to be a little bit more expensive. You always want to assume SSD storage for databases. In my experience, the spinning disk solutions just don't provide enough I/O. Your I/O costs may or may not be included in your storage bill. In the case of Azure, if you're using premium storage, all the I/O is free. You get all the I/O you can use. But if you're using standard storage, which is a lot cheaper, your I/O is metered. So you get a certain amount of free I/O, and then you have to pay beyond that. And I know people always get scared. I do too, whenever there's a billing structure that works out that way. Networking is mostly included. Understand your provider and understand what you need to know, and if you're paying for anything. Sometimes you have to pay for data across regions. Sometimes you don't. That can partially depend on the service involved. It can also partially depend on your cloud provider. And data into the cloud is always free. Data out is always paid. I have that asterisk there because if you have ExpressRoute or Direct Connect, depending on who your vendor is, that's something that you can buy in such a fashion where you don't have to pay for that data out. So some basic cloud design principles. If you're not familiar with microservices architecture, it's kind of something that came out of Google and pretty much I'd say the last decade, where we build these like containers. It's not necessarily containers, but you build small services that all interact over APIs. And they manage your resources effectively. Those are things that are really good. You want to be able to take advantage of autoscale where possible. So on things like application servers and web servers, taking advantage of autoscale is going to be kind of a major benefit in how you support your applications. And that's going to reduce your costs because you're going to get autoscale out, but you'll also get autoscale down when your workload is reduced. Like I mentioned, you can use caching to reduce your database load. This is going to work best on read-intensive workloads. Your larger VM should be used sparingly. And here's what I kind of mean by that. If you have five or six very large database machines, in the context of all the savings you might be getting across all your other services, if you're moving a lot of workloads to the cloud, those VMs won't be that expensive. But if that's all you're running, your bill's gonna feel really large. You want to avoid returning large amounts of data back to your on-prem environment, like we mentioned. Understand how your users are using your data and give them good reporting options. Understand data movement between regions. If you're doing HA and DR in the cloud, you may be paying for that data transfer. So it's important to understand how your cloud provider works. And then understand your high availability and disaster recovery needs. And I'll also add to this, understand your licensing. There's one scenario that I've always found really odd with Microsoft licensing for SQL Server is that if your on-prem is on-prem, or if your primary rather is on-prem and your DR site is Azure, you no longer get that free secondary license with software assurance. You actually have to pay for it because Microsoft considers that two different compute platforms. I find this really odd, and I've argued with the guy who sets the rules for licensing. a few times because I think it would be a great way to encourage sales into Azure. But if you're in that scenario, you have to license both sides of your primary and secondary. Whereas if you were either all in Azure or in two different on-prem data centers, you wouldn't have to do that. It's a little bit wonky, and then also make sure you understand the scenarios where you bring your own license versus using your own license. The other place where this starts to get kind of interesting is buying licenses versus renting licenses. One scenario we've done with a few customers over and over again is rented licensing for SSIS. And there is a platform as a service offering called Azure Data Factory, but it does tend to be a little bit more expensive than this approach. Where we've had customers that have done ETL 3 or 4 times a day, we use automation to turn on their VM, run their ETL processing, and then turn off their VM. We rent the SQL Server license because we're only renting it for however long their ETL runs, which is usually less than a couple of hours a day. And the costs are next to nothing to do something like that. So that's been kind of a really good approach for us on that. So cloud design, only back up your data. Don't worry about backing up servers. Your servers should be scripts. Your infrastructure is code. Understand what workloads need to be online 24/7. Not everything does. Think about your overall system architecture. Lift and shift migrations, where you just take everything and move it into the cloud, tend to be the most expensive. You want to think about what things can get into, platform as a service architectures or database as a service architectures. Those sorts of solutions tend to be cheaper and more flexible overall than doing a large scale lift and shift of the application. So think about that design pattern and then reduce your footprint where possible. I'm not telling you to go cut your servers in half, but think about doing things like auto scale and understanding where your workloads are and what workloads you can cut down. So one common problem I've run into is who built what resource in the cloud, or what department is responsible for it. And this is a screenshot from the Azure portal from an actual customer whose subscription has been blocked out. But we have this notion of tagging. All major platforms have some notion of this tagging resources. These tags are key value pairs. And so in Azure, you can have, I think, up to 15 per resource, and you can put them on each resource. So if we think about a resource model, I'll just walk through what a VM looks like in Azure. The VM itself is a resource. The network card of that VM is a resource. And then the underlying storage is also a resource. Those things all kind of roll up together to provide one unified VM. But you can tag each of those things independently. So you can say, the storage is a certain type. However, the two really, really big things I want to see in almost anyone's cloud environment, and it's missing on this one, is that environment production. So environment production is there. I want to see if it's production, dev, QA, stage, test, whatever. But I also want to see the cost center or department name. And this, because the reason for this is on your bill from your cloud provider, these tags will be stored with which each line item. So one of the things you can do from here is dump your bill into Excel or dump your bill into Power BI. And when you do that, you can kind of have a better idea of who's responsible for what, and who to yell at if somebody's over allocated their cloud. So tags are extremely useful. And so how do we want to enforce this? This is, to me, it's probably the most important part of cloud management, just classifying resources and knowing what's in your cloud. Both Amazon and Microsoft have this notion of policy. This isn't that dissimilar than group policy in Windows, but it's a much, there's a much smaller hierarchy and much less complexity. So one of the ways you can use a policy is you can say all resources must have a tag of environment and cost center before they can be created. Unfortunately, you can't, as of now, specify a domain for those. So you can't say that only production, dev, test, QA are supported environment types. But you can you can not allow any resources to be created without those tags. So that's kind of the first step of ways I like to enforce policy. The second step of how I like to enforce policy is to potentially limit the number of resources that can be created. So you can kind of build your own service catalog in this, where you could potentially say you can only use these VM types for development machines. And anything else would require special approval. And you can always override the policy depending on how you apply it. You can also add some complexity. So you can take advantage of the logic that you've put into policy and enforce tags. And you can say all non-production VMs get shut down at 7 p.m., whether anyone likes it or not. That's kind of the big hammer approach. And you may want to wait to use that if you're kind of starting to experience some financial issues with your cloud. But that's something to be aware of, that once you tag everything, you can start to take advantage of things like that. It just makes reporting and all those things a lot easier. You can also use this policy to limit the locations that are available to your cloud. So some other hidden costs, we've kind of talked through most of these, but networking is usually the biggest. I/O, if you have disks that are metered. Services that have complex costing models, like that Cosmos example I was talking about, where you could get burst pricing if you're accelerating too much. In general, those services tend to save you money, but they're less predictable, so that can be a little bit frustrating for a lot of folks. And then finally, licensing. So if you did your licensing wrong, or if you had a license and you brought it, or you didn't bring it, or didn't use a bring your own license image, that can be problematic. Another scenario, another licensing scenario that I've seen that I don't think Microsoft has addressed is if you're renting your SQL Server license, there's no notion of a free DR copy, even though there kind of should be. So it's one of the advantages of bringing your own license for SQL Server. And discussing renting versus buying of licenses is a whole kind of another talk almost. So in summary, you're going to want to collect a lot of data up front. So you're going to want to right size your cloud, and you're going to want to see where you can consolidate resources, potentially even consolidate servers. Sometimes it can make sense to consolidate database servers just to reduce your overall VM footprint. That's part of the migration I'm doing right now. And then you want to understand where you can re-architect solutions for lower cost. So if you can move something into more of a scale add model, that's always a benefit. And then tag your resources so that you understand who built what and who's responsible for what cost. And then finally, you can use policies in order to kind of build a service catalog for your own environment. And now I'm going to hand off to Dave, who's going to show high availability and disaster recovery in the cloud.
Great, thanks, Joey. Greg, if you could pass control to me, I'll share my desktop, and we'll talk about high availability and disaster recovery in the cloud, and how it kind of ties into some of what Joey's saying, especially in cost savings. So with SIOS, product called SIOS Data Keeper, we can have a failover cluster in the cloud using SQL Server Standard Edition, which can save you a boatload of money in your SQL Server licensing. So there's that, and there's also some technical advantages of why you would want to build a failover cluster in the cloud as well. So I won't bore you with too many slides, but just give you a little technical overview, and then I'm going to give you a demonstration of the SIOS Data Keeper solution to build failover clusters on the Windows platform. And I also want to show you the SIOS Protection Suite, which is another way to actually save some money. If you want to leverage the Linux operating system and deploy SQL Server on top of Linux, of course, with SQL Server 2017, that's a possibility as well. And you can do the math, but there's some cost savings to be had there as well to using Linux OS versus Windows OS.
It's definitely non-consequential when you start talking about very large VMs, Dave. I just wanted to add that. The Windows cost on smaller VMs, not so big, but when you get to like 64 cores, it gets expensive.
Yeah. So traditional failover clustering, hopefully you're familiar with. It's 2 or more nodes connected to some sort of shared storage device. as you see here. And that shared storage is just not available in the cloud. So you can't typically deploy a failover cluster leveraging just what the cloud provides you in terms of storage. So that's where the SIOS Data Keeper solution comes in, and we allow you to build what we term a fanless cluster leveraging our software. So basically our software does two things. It does block level volume replication, either synchronously between two nodes in the same region or asynchronously between nodes in different regions, or even from on-prem into the cloud or vice versa in hybrid cloud configurations. And besides the replication, we integrate with Windows Server failover clustering through a cluster resource we call a Data Keeper volume. The Data Keeper volume controls the mirror direction. So in normal operating circumstances, as pictured here, two nodes, with node 1 being online and all the writes occurring there and being replicated to node 2. Now, should there be a failure of node 1, failover clustering, as it would normally, would detect the failure and will initiate a failover to the standby node. And now with SQL Server running on node 2, all the writes are occurring on node 2, and any remaining node is now the target of that mirror. So all that happens automatically as part of the failover. We can also support multiple targets. So pictured here is a typical configuration with two nodes, maybe in the same region, doing synchronous replication for high availability, but at the same time, we're replicating off-site to a third node for disaster recovery. Now this works with SQL Server Enterprise Edition as pictured here with all three nodes in the same cluster, but we can also do this with SQL Server Standard Edition, but due to the limitations that Microsoft has put on the Standard Edition, only node 1 and 2 would be part of the cluster, and node 3 would have a real-time copy of the data, but recovery in the DR site would be more of a manual intervention, mounting those databases and redirecting your applications to that DR site. So the SIOS Data Keeper, just in a summary, it's host-based replication, block-level replication across the WAN or LAN, multiple targets. It's integrated with failover clustering. You'll see in the demonstration here in a moment. And it's very low overhead. So that's one thing to keep in mind. Besides, the cost savings of using Standard Edition, there's some technical benefits of using a failover cluster with Data Keeper versus really the only other alternative would be the always-on availability groups. One of the things with the availability groups, as you add more databases, you start to consume more worker thread processes. Eventually, you run out of resources. And, Microsoft will tell you, approximately how many you're going to have per, it's very dependent on, obviously, the hardware you're running on top of. But with the block level replication, to us, it's just ones and zeros in a disk. So we don't care whether you have one database or 1 million databases. It's not going to create any additional overhead. And so CPU consumption is minimal, RAM consumption is minimal. About the only overhead you'll see is on the network, so you just need to manage your network to make sure you have adequate bandwidth, especially in the WAN type replications. Just a real quick summary of the SIOS protection suite for Linux. So as I mentioned, with SQL 2017, you can now run SQL Server on top of Linux, and that's a great solution, especially if you are, or if you're a Linux shop already and you're looking for alternatives to, Oracle, or just looking at maybe introducing some SQL Server into your environment, but you're not quite ready to embrace Windows Server as an OS, or we talk about the cost savings as well. We have an HA solution, and we actually have been selling high availability for Linux for quite some time via the SIOS Protection Suite for Linux. So what the SIOS Protection Suite is, it includes SIOS Data Keeper. So we still do the block level replication, synchronous, asynchronous, LAN, WAN, all that is similar to what we have on the Windows platform. But we also deliver the HA component as well. So we deliver the SIOS Lifekeeper solution, which does very much what Windows Server failover clustering does. It's going to monitor at the system level and the application level going to recover storage and networking and also compute, the application layer. So through our application recovery kits, we provide application-specific monitoring and recovery. So all the major database platforms and applications from Oracle to SAP and more are provided protection out of the box, including SQL Server as well. So we have the SQL Server Recovery Kit that will let you monitor and recover SQL Server running on top of Linux. So let me jump over to some demos so you get a look of how this works. So we'll start with the SIOS Data Keeper running on Windows demonstration. So I have it recorded here. We'll go back to the beginning and we'll just talk through this demo and then we'll jump to the Linux demo. So as I mentioned, it leverages Windows Server failover clustering. So if you're familiar with failover clustering, you already know 99% of the solution. The only thing we're doing is adding some storage plugin that lets you leverage local storage. So I have failover cluster manager up and running, 2 nodes in this cluster. I have a SQL Server cluster instance already configured. It's got your name and IP, nothing new here. But under storage, you see something called a data keeper volume. We look at the properties of that. We can see that this is different. This is not your shared disk. This is a replicated volume. So we can get some information about the replication rate from failover cluster manager. We see this current source and target, the mirror type. It's currently in the mirroring state. So this kind of makes sense. It's running on SIOS 1, replicating to SIOS 2. And then other than that, I control it like a regular cluster. So if I want to move this resource to SIOS 2, I do that through failover cluster manager. Things will switch over. As part of the switchover, you watch the volume resource. So we'll go offline and online very quickly, as you'll see. And what that did is it changed the mirror direction. So now the mirror is active on SIOS 2 and replicating back to SIOS 1. So again, same user experience. And an unexpected failure scenario, now we're running on SIOS 2. I'll just stop the cluster service on SIOS 2. And of course, failover clustering is going to detect that as a failure, and we'll initiate a switch over to SIOS 1. So we'll see things going offline, online. And again, so that all happened automatically as part of failover clustering, just like you're used to today, but we're leveraging locally attached storage, so this enables clustering in the cloud. I'm going to turn the node back on, and I'll show you how easy it is to configure this. It's just software running on each of the cluster nodes. So Datakeeper is running on SIOS 1 and SIOS 2. And the configuration is done through our interface shown here. We see the existing job, the SQL Server job that we just saw in the cluster. But now we're going to create another job and we're going to replicate the R drive. The R drive is just local storage attached to that node. Each node will have an R drive, same size. Kick off this new job wizard, give it pick the source, pick the volume. You can choose which network to use for replication traffic and click next. Choose a target, SIOS 2, it looks good. And then here's some options. So for nodes in the same region, synchronous replication is all you need to choose. If you're doing cross-region replication or hybrid cloud from on-prem to cloud, you would choose asynchronous. You can also enable some compression, some bandwidth throttling to save on that cost that Jelly was telling you about. If you're replicating outside, all the egress data you have to pay for, so you can save some money by compressing that data as well. But synchronous is all you need to choose for a local target, and then that initiates the replication. Then in the moment, we get a pop-up that asks us if we want to register this in the cluster. We'll say yes, go ahead, put that in the cluster, and we'll see back in Failover Cluster Manager, now we have a Datakeeper Volume R coming online. It's in available storage. At this point, Failover Clustering treats that like a regular disk. So if I want to create a file server cluster, I could do that. I could do a standalone file server cluster just like I would, create a new SQL Server cluster. You're going to walk through the wizard, give it a name, give it an IP address. And the same thing for SQL Server clusters, I'll just run the SQL setup and it would recognize the Datakeeper volume shown here as an available storage location. So there's the Datakeeper volume R we just created. Everything looks good, and we'll click next, finish, and that's it. So very simple, very easy to use. If you're familiar with failover clustering, it's a no-brainer. It works exactly the same way. So let me jump over to our Linux solution. So the SIOS Protection Suite, and what I have configured here is actually a SQL Server failover cluster running in Azure. So we'll start out in the Azure portal just to show you the VMs I have configured, SQL 1 and SQL 2. We'll see they're in an availability set, which is requirement for HA, and we have a witness server as well, and they're all running in different fault domains. So we're not going into too much detail. This is the redundant area of Azure here. Of course, they're running on a Linux OS, and this is the interface. So let's take a moment just to take a look at this interface. It's very easy to understand. We have the two servers across the top. We have a witness server in here as well. And then we have a hierarchy very much like the Windows Server failover clustering hierarchy. We have the SQL Server, we have the data replication, we have the volumes, we have an IP address, and we have everything active on SQL Server 1. And I'm going to kick off, I'm going to connect to SQL Server Management Studio, and I'm going to kick off a query that starts inserting 10,000 rows into this database. So we'll kick off this query, and then I'm going to do a manual switch over. So we're going to start running this query, and we'll see how many rows we can insert before the before we switch over and SQL comes offline. So we initiate a switch over. Things are coming online on SQL 2 in a moment. We'll see the query is disconnected, so things are going offline. So it's disconnected. We'll see how many rows we got inserted before we actually shut down SQL here. We'll scroll down, and we can see we had 2434. So 2,434 rows inserted before SQL was shut down. Now we're going to come online on SQL 2. So we're again switching the mirror direction. We're going to bring the SQL Server resources online, recover the IP address. All that happens automatically. So as we're coming online here, after that completes, we're going to do a select query and look at the max value to see how many of those rows got replicated. Now, I can tell you we're doing synchronous replication, so I'm expecting all rows to be over there. So let's take a look. We're reconnected to the database. We're going to run the select max in that table here. And we'll come back and we'll see there's the 2,434 rows. So all the rows were replicated. The connection was made automatically. I didn't have to reconnect to that database. And so it's very simple. Again, if you're thinking about running SQL Server on Linux, and especially in the cloud, and Microsoft will tell you this themselves, there really is no HA solution for Linux on SQL running in the cloud today. Now, some of the OS providers are working on that, so I'm told. But if you're looking to deploy SQL Server on Linux in the cloud, then the SIOS DataKeeper solution is really something that you want to consider. I know we're running short on time, so I'm going to stop the demo here. And I think we have some questions in the queue, so we'll spend the rest of the time just addressing those questions. But if you want to see more about this, definitely reach out to SIOS. There will be some contact information at the end. We'll be glad to do a personal call with you as well.
Okay, thanks, Dave. Yeah, there's a few questions we'll take, and we do have a couple minutes here. And if we don't get to the question, we can definitely forward the information on to either Dave or Joey, and they can get back to you as time permits. So one question someone had was related to using platform as a service, infrastructure as a service, and is one route cheaper than the other route, and does it make sense to go one direction versus the other moving to the cloud?
I'll let Joey address that one. Joey, you on mute? No, Joey. So platform as a service, the expense involved there is the is the learning, right? So you gotta re-architect, and you gotta test and verify that your application is going to work using platform as a service. Joey, you're back. You have?
Yeah, what Dave said. It's usually cheaper to run platform as a service, but there's more cost around architecture changes that you'll need to do to run in that scenario.
Okay, let's see. Another question related to SIOS Data Keeper. So I'll just read it as it came in. It says, does SIOS support mount points in addition to drive letters?
No, so mount points are basically pointers to other volumes that aren't necessarily being replicated. So we do not support mount points, it's just drive letters.
Same. All right, well, I have a hard stop, so unfortunately I have to drop off. But Greg, if you could forward the questions, I'd be happy to address any of them on a blog or something.
Okay, will do. Cool. Okay, thanks, Joey.
All right, thanks. Bye.
All right, Dave, just one last question, and we'll just wrap things up here. So question from Dave is, will DataKeeper and other SIOS products allow a company that's using SQL Server Enterprise Edition for HA to be able to just use the standard edition and take advantage of everything that clustering has to offer?
Yes, yeah, and we see that very often. People are looking to avoid the expense of Enterprise Edition, but they still need high availability. And the always-on availability groups, the full featured version is only available in the Enterprise Edition. So we can build failover clusters, the standalone version of a failover cluster with SQL Server Standard Edition, and we are seeing cost savings in the 70% realm when you compare a always-on failover cluster, the availability group failover clustering versus the standalone DataKeeper version. You can see quite a cost savings.
Okay. One other question, Dave, is somebody wants to know, with the examples that you showed with DataKeeper, it was both, I guess most examples were 2-node clusters, and they're just wondering, can you do a multi-node cluster? And if so, do you need enterprise editions of either Windows or SQL to accommodate that?
For the Windows, Microsoft limits SQL Server Standard Edition to 2 nodes. However, we can support replicating to a third node. Excuse me. It's just outside of the cluster. You can't put that third node in the cluster. With the Enterprise Edition, of course, it can be included into the cluster, so we can support multiple nodes. So 3 and 4 nodes is kind of the sweet spot. There is no upper limit, but typically that's what we're seeing deployed when you go beyond 2 nodes.
Okay. All right, great. We're going to wrap things up. So thank you to Joey, and also thank you to Dave for sharing that information today. And I also want to thank SIOS for sponsoring today's webcast. The webcast was recorded, and you'll receive a follow-up email with links to view the archive and also have the ability to download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.